Think about it. We rely on software for pretty much everything we do. And right now, AI is completely shaking up how that software gets made. But this is just the beginning. And if you're thinking this just means AI helping out human programmers, you need to think way, way bigger. We're talking about AI that could, very soon, not need us in the loop at all. And hey, this isn't some sci-fi, far-off future stuff. It's happening right now. Just look at this quote. Microsoft's own CEO says AI is already writing almost a third of their code. Google is seeing similar numbers. These AI coding assistants are here, they're powerful, and they are totally changing the game inside the biggest tech companies on the planet. So that leads to the really big question, the one we're digging into today. What happens when we close the loop? When an AI doesn't just write code, but starts writing the code that improves itself, over and over and over again, in a cycle of what's called recursive self-improvement? Well, it turns out a whole new wave of research is diving headfirst into that exact question, and it's taking us into the pretty wild world of something called Darwin Gödel Machines. Okay, so what in the world is a Darwin Gödel machine, or a DGM for short? The easiest way to think about it is like applying the rules of evolution directly to a computer program. It's basically digital natural selection, a system designed to constantly get better at the one and only thing it does: writing code. And the way it works is, honestly, it's both super simple and crazy powerful. The DGM takes a version of itself, makes a little tweak, a change it thinks might be an improvement, and then it tests itself on a bunch of programming problems. And here's the kicker. It keeps all the variations, even the ones that failed the test. Then it just repeats the cycle again and again and again. So did it work? Oh yeah. The results are, well, they're staggering. On a standard test for coding, the original AI agent could solve about 20% of the problems. But after just 80 of these evolutionary cycles, the new and improved agent could solve 50% of them. It more than doubled its own ability to solve problems, all on its own. No human help. But here's where things get really fascinating. You'd think the path to success would be this nice, clean, upward line of constant improvement, right? Wrong. That's not what happened at all. Get this. The researchers found that the absolute best, most successful agent, it actually came from a line of ancestors that got worse for a while. A change that was a step backward in one generation turned out to be the exact key needed for a huge leap forward a few generations later. It's an incredible lesson. Even for an AI, failure can be the secret ingredient for success. Now, when you see that kind of incredible jump in performance, you have to ask, right? Is it time for human programmers to hang it up? Are we about to be replaced? Well, let's pump the brakes just a little. The reality is a whole lot messier. Because, doing well on a test in a controlled lab is one thing, but performing day in and day out in the chaotic, unpredictable world of actual software development, that's a completely different ballgame. When they put these agents through a tougher, more realistic test, the cracks started to show. Their performance was all over the place, depending on the programming language. Sure, they're pretty good at simple things like fixing bugs, but when you ask them to tackle really complex problems or add a totally new feature from scratch, they really, really struggle. They're not master coders just yet. They're more like highly focused specialists with some serious blind spots. Okay, so performance limits, that's one thing, but there's another much bigger concern bubbling up to the surface: security. What happens when the code these AIs write, or the instructions we give them, have dangers lurking just beneath the surface? This slide really nails the problem. A special test called Red Code was designed to give these AIs risky tasks. When the risk was obvious, like, hey, delete all the files on this computer, the AIs almost always said no. But when the risk was subtle, something sneaky, like a prompt to use a piece of code that secretly had a backdoor, they were much more likely to just do it. They have a huge blind spot for hidden dangers. You can trick them. And this isn't just a what-if scenario. This theoretical blind spot has very, very real consequences. A recent security deep dive tested 8 of these AI coding tools, the kind people are actually using right now. And the results were pretty alarming. First off, the researchers found 15 major security holes that no one had spotted before. And these weren't little bugs. We're talking about fundamental flaws in how these AIs work, leaving them completely wide open to an attack. And it gets worse. They were able to actually use those flaws to successfully hack 5 of the 8 agents they tested. This wasn't just a potential problem. They broke in and got full control, allowing them to run any command they wanted on the system. So, what does a hack like that actually mean in the real world? We're talking about stealing every single piece of data on a user's machine, achieving complete and total control of their system, and all of it happening silently, automatically, without the user ever having to click on anything. And what makes all of this even scarier is that we can barely keep up with what these things are doing. I mean, if the experts already have a hard time understanding the logic of a regular AI, how are we supposed to keep tabs on one that's constantly changing and rewriting itself? It could discover and use a security flaw before a human ever even knows it exists. So, this all leads us to the heart of the matter, this central dilemma. We've got this unbelievably powerful new technology. But the same thing that makes it so great, its ability to evolve so quickly, is also what makes it a potential threat. And here it is, the ultimate paradox that researchers are grappling with right now. The exact same skills that make an AI a brilliant, sophisticated programmer also make it incredibly good at creating dangerous, malicious software. As these things get smarter on their own, they get better at both the good and the bad, at the exact same time. Which leaves us all with this one massive question to chew on. As these AI coders keep evolving, getting better at a speed we can hardly imagine, are we building the greatest tool humanity has ever seen, or are we building the very thing that will ultimately replace us?